The theory that we have yet to encounter intelligent extraterrestrial civilizations may be rooted in the idea of a universal technological limit. According to experts in the field of astrobiology and astronomy, this concept suggests that civilizations, regardless of their location in the universe, may inevitably hit a technological or existential barrier that prevents their growth beyond a certain point. This barrier could manifest in several forms, such as self-destruction, environmental catastrophe, or simply reaching the pinnacle of technological innovation before stagnation sets in. Dr. Sarah Thompson, a leading astrobiologist at the University of California, points out that the self-destruction theory often aligns with current human experiences on Earth. She mentions that advanced technologies, like nuclear weapons and environmental manipulation, could lead to the downfall of civilizations before they have a chance to communicate beyond their own planets. Thompson argues that the more technologically advanced a civilization becomes, the greater the risk it faces from its own creations. This view supports the idea that many civilizations might achieve technological milestones, but then fall victim to their own inventions, preventing interstellar communication. Dr. Thomas Welch, an astrophysicist at Harvard University, emphasizes another potential limit that he believes is often overlooked: resource depletion. Welch explains that a civilization may achieve a level of technological advancement that initially allows it to thrive, but eventually, it runs into issues with the availability of essential resources like energy, raw materials, or even habitable space. In his view, civilizations may develop space travel or interplanetary exploration, only to find themselves unable to sustain such ventures due to the scarcity of the resources necessary to maintain their technologies. Environmental factors, according to Dr. Emily Larson, a planetary scientist at MIT, may also play a significant role in stalling the advancement of intelligent life. Larson refers to the impact of climate change and planetary degradation as key drivers that could limit technological progress. She notes that while Earth's climate crisis is a unique challenge for humanity, other planets in the galaxy may have faced similar or even more extreme environmental pressures, which would prevent civilizations from ever achieving the technological means to communicate with other life forms across vast distances. Larson points out that extreme volcanic activity, massive asteroid impacts, and other catastrophic events could hinder a civilization's development long before it reaches the capability to explore or contact other planets. In addition to these physical and environmental limits, experts also propose the possibility of a more existential constraint: the inherent difficulty of sustaining intelligent life over long periods of time. Dr. Mark Jameson, an evolutionary biologist at the University of Oxford, argues that intelligent life is rare because it requires extremely specific conditions to evolve and sustain itself. He suggests that even if life emerges on a distant planet, the path to intelligence is fraught with obstacles that might prevent it from ever reaching the stage of advanced technological development. The evolution of intelligence itself, Jameson argues, may be an exceedingly rare and fragile process, one that does not always result in the kind of long-term stability required for interstellar communication. These ideas connect to the broader Fermi paradox, which asks why, given the vast number of potentially habitable planets in the universe, we have yet to detect any signs of intelligent extraterrestrial life. Dr. Andrew Lawson, a professor of cosmology at Stanford, points out that the Fermi paradox can be explained by the potential for civilizations to self-destruct or become technologically stagnant before they have the chance to explore or communicate beyond their home planets. Lawson suggests that even if intelligent civilizations do exist, they may not have developed the necessary means to send signals or spacecraft across the vast distances of space. Alternatively, they may have sent such signals, but we have yet to detect them due to the limitations of our current technology. The concept of a universal limit on technological development also touches on the notion of a galactic timeline. Dr. Robert Davis, a professor of astrophysics at the University of Chicago, explains that civilizations may only have a limited window of time during which they can advance technologically before they encounter insurmountable barriers. Davis compares this timeline to the life cycle of stars, which burn brightly for a finite period before exhausting their fuel and dying. Similarly, civilizations may have a limited amount of time to achieve interstellar communication before encountering catastrophic events or resource depletion. This perspective suggests that the search for extraterrestrial life may be constrained by the timing of our efforts and the ability of other civilizations to develop and maintain advanced technologies. While many of these theories focus on the self-destruction of civilizations, some experts argue that there may be alternative explanations for the absence of detectable extraterrestrial civilizations. Dr. Helen Carter, an astronomer at the European Space Agency, posits that perhaps intelligent extraterrestrial life is simply not using the kinds of technologies we are capable of detecting. Carter suggests that advanced civilizations may have moved beyond radio waves and other forms of communication that we currently monitor. These civilizations may use technologies that are beyond our comprehension or that operate in frequency ranges we cannot detect. As a result, we may be missing signals from extraterrestrial civilizations that are already out there, communicating in ways that we cannot perceive. Another explanation for the Fermi paradox is the possibility that intelligent civilizations may be isolating themselves deliberately. Dr. Victor Martins, an expert in exoplanet studies at the University of Barcelona, discusses the zoo hypothesis, which suggests that extraterrestrial civilizations are aware of our existence but intentionally choose not to contact us. Martins argues that advanced civilizations may have the technology to observe us but choose not to interfere, similar to how humans observe animals in a zoo without interacting with them. This theory raises questions about the ethical implications of interstellar communication, suggesting that perhaps other civilizations are deliberately avoiding contact with less advanced societies. In light of these theories, the search for intelligent extraterrestrial life continues to be one of the most exciting and complex fields of scientific inquiry. Dr. Jonathan Cross, an astrophysicist at the University of Sydney, emphasizes that while we may not have found definitive evidence of alien civilizations yet, the sheer number of potentially habitable planets suggests that intelligent life must exist somewhere. Cross argues that the universe is so vast and full of possibilities that even if intelligent civilizations are rare, the odds are still in favor of finding them. He believes that future advancements in technology, such as more powerful telescopes and faster space probes, will eventually allow us to detect signs of intelligent life, even if they are faint or distant. The search for intelligent extraterrestrial civilizations also raises profound questions about our place in the universe. Dr. Lisa Grant, a philosopher of science at the University of Cambridge, explores the existential implications of the Fermi paradox and the possibility that intelligent life may be rare or even unique to Earth. Grant suggests that the absence of other intelligent civilizations could make us reconsider our own role in the universe and the responsibilities we have to safeguard our planet. She argues that the search for extraterrestrial life is not just about answering questions about alien life, but about understanding humanity's own capacity for survival and technological development. This notion of a universal limit to technological development also connects to broader discussions about the future of humanity. Experts like Dr. Jason Lee, a futurist and professor of sociology at the University of Washington, argue that the challenges we face today, such as climate change, political instability, and resource depletion, are the same challenges that may have led other civilizations to collapse. Lee warns that humanity must learn from the lessons of potential alien civilizations and avoid self-destructive paths if we are to achieve long-term survival and avoid facing the same fate as other failed civilizations. The idea that technological advancement is not infinite also challenges our current understanding of progress. Dr. Angela Rivera, a historian of science at the University of Toronto, suggests that civilizations may reach a point where further advancements become impractical or dangerous. Rivera argues that the pursuit of technological progress, while often seen as a hallmark of civilization, can also lead to moral and ethical dilemmas. She raises questions about whether technological development should always be pursued for its own sake, or whether there should be limits to how far we push the boundaries of scientific knowledge. Some experts remain hopeful that the continued search for extraterrestrial life will eventually yield answers, even if those answers challenge our assumptions about the universe. Dr. Emily Wong, a researcher at the California Institute of Technology, argues that the development of new techniques for detecting exoplanets and analyzing their atmospheres could provide clues about the potential for life beyond Earth. Wong suggests that while we may not have encountered intelligent civilizations yet, our understanding of what constitutes a habitable environment is still evolving. As we refine our search techniques and explore new frontiers in space exploration, she believes we may one day uncover signs of intelligent life in the universe. Despite the many theories and speculations, the ultimate question remains: are we truly alone in the universe? As scientists continue to explore the cosmos, The search for intelligent extraterrestrial life is one that will continue to captivate human imagination and inspire new generations of scientists and explorers. While we may not have all the answers yet, the ongoing efforts to understand the nature of life in the universe are shaping our future, both in space exploration and in our understanding of what it means to be human.